Coming to you from the Windy City. Welcome to Let's Talk Shop, a podcast about all things cloud and enterprise tech. Listen to insights and guest interviews with IT thought leaders and professionals. Now, here's your host, Elias Khnaser.
Welcome back, everyone, to another episode of Let's Talk Shop. My guest today is a very special guest, Dave Brown, Vice President of Elastic Cloud Compute at Amazon. Dave, it's awesome to have you on the show.
Well, Elias, it's fantastic to be here. Thanks for having me.
Absolutely. So I want to start by quizzing your knowledge of AWS, some AWS trivia. So since you are the VP of EC2, why is it EC2 and not EC3 or EC4?
It's a great question. And this actually takes us back to the early days of AWS. And when we first started naming our services, S3 was one of the first ones we named, which is our block store or object storage service. And that was actually simple storage service. And so the contraction of that, or the abbreviation, became S3. And at the time, actually, EC2 was still in development. And the internal name for EC2 was actually the Amazon Execution Service. And so we thought that was probably not a good idea to call it the execution service, given the connotations of that name. And so just before launch, we named it the Elastic Compute Cloud, so ECC. And so then if you contract that in the way that we were doing back then, it became EC2 for the double Cs. And we were actually just talking last week, that was the first service that ever used the word cloud in the way that we use it today when we talk about cloud computing. So Elastic Compute Cloud, EC2.
That's awesome. I think you guys should bring back those small nuances so that people can figure it out. Like 3 S's for S3, 2 S's for EC2. Those were
exactly. We were actually. I was in a meeting last week, and I was teasing the team, saying, we do these naming meetings, and sometimes people joke about the names we choose, but we do actually spend a lot of time thinking about them, maybe too much time. And I was teasing the team, saying, maybe we need to get back to our roots and have a few more like EC2s or ED2 or whatever it might be that we were thinking about.
Yeah. Back to the roots is always good.
Yeah.
So you're the VP of a pretty big portfolio. EC2 is pretty big, but what else falls under EC2? What else are you responsible for?
Yeah, so EC2 is sort of my main role, but it makes up a couple of different areas, and the first one's obviously all of our instances. So we have over 500 instances today across very different types of machines and different types of workloads. Speccing out those instances, deciding what they're going to be, what we're going to go after, actually building those machines, writing the software that's needed to manage them. That's all in my organization. So all of our instance types. The next thing is the networking. An instance is useless if you can't connect it to a network and talk to other instances. So everything you see in AWS from a networking point of view. So that includes VPC and Transit Gateway and Private Link and NAT Gateway. And then actually the load balancing products as well. So Elastic Load Balancing and API Gateway. So all those networking features form part of my org. And then also compute's a little useless if you don't have a really good storage solution. So, the storage that works closest with EC2 is the Elastic Block Store EBS, which is sort of our network attached storage solution for EC2. So EBS is also part of my team. And then a newer area for us, in the last couple of years, I think we launched the first one in 2020, is our edge computing strategy. And so this is really about us with products like outposts and local zones and wavelength. And how do we take our compute and we take it outside of an AWS region and actually bring it closer to the customer? So Outposts is in the colo facility or in the data center. Local zones, we have over 16 local zones now in the US, actually servicing metropolitan areas with very, very low latency. So that's the entire portfolio, and it's a lot of fun.
You also have wavelength, correct?
I do have wavelength, that's right, yes.
So if I were to sum it up, you pretty much have all of IaaS for the most part.
Yeah, for the most part, that's true. I mean, the other parts that would fit into IaaS would be containers and Lambda in the serverless space. And, that's a peer organization and a Deepak Singh. And they're customers of EC2. So, don't tell anybody that I told you that Lambda actually does use servers. The whole marketing campaign relies on people thinking that they don't use servers with serverless. But Lambda is a great customer of EC2. Containers are a great customer of EC2, just like some of your viewers would be customers of EC2 as well.
Yeah. All right, so you mentioned 500 instances of EC2. For me, as someone that's grown up with AWS, I can appreciate how we got to 500 plus instances. For some customers, it's just confusing. Sometimes you can find the same instance that works for the same app. Is there, and I know it's difficult because, again, you've got hardware refreshes, you've got CPUs, you've got overlap. it's difficult, but is there a way to potentially simplify this? Maybe recommendations by the type of workload, as a lot of customers use workloads, you have a lot of information on what works best with SAP or
Yeah.
VMware or IoT. Is
Yeah.
there a direction to simplify the choices?
Yeah, absolutely. And it's something we think about, almost every time I say the 500 instance types, I'm thinking, how do customers choose? And, we got to this place over the years by thinking about how do we win that next workload? What is that next workload that we're going to need to have a type of machine or a certain capability or enough memory or accelerator like a GPU to allow a customer to actually bring that workload to AWS, right? When we launched AWS, we had one instance. It didn't even have a name. It ultimately became the M1 small instance as we brought more instance types out there. But what happens with customers today is they have a workload, they have a pretty good idea of which instance type it would fit into. It's very much like trying to buy a server for your data center, or like a laptop spec, and you're trying to look at the instance type. That's what they are. And ultimately, you'd kind of narrow it down to a handful of instances. And then, as you say, you've got to think about: do you want to use the latest accelerator from NVIDIA, for example, or do you want to use the very latest CPU from Intel? Or do you want to use one of AWS's CPUs with Graviton? And they all have benefits and things that you want to think about. The other thing we do have is we actually have a service called Compute Optimizer, which can look at your workload. So customers that have deployed today, you can go in and enable Compute Optimizer, and it'll actually look at all of your workloads and how you're using the underlying instance, and then make recommendations about how, should you go for a smaller instance type? Would we recommend you scale up? And it really is in the cost optimization space. And so a lot of customers, as they're working to build better mechanisms and better muscle around managing AWS costs across an organization, are getting a lot of value out of Compute Optimizer. But finding ways to simplify the instance area and selection of those is something that we continue to focus on and make sure we're helping customers there.
I'm glad to hear that. I mean, again, I can appreciate the position that you guys are in. It's not easy, and there's a lot of things going on, but from a customer's perspective, the more simplification with the broader choices is always welcome. But you mentioned Graviton, so I want to pivot a little bit. AWS has been talking about custom silicon for a while now. My question, and I'm sure a lot of the audience is also that are listening or viewing this, is why should I care about custom silicon? Like when I'm choosing an EC2 instance, and I'll be very honest with you, I don't remember the last time I checked whether it was Intel or AMD or even AWS. So why should I care?
Well, I think, so firstly, just to say, I don't think it's so much, the customers aren't choosing and we aren't looking at which brand. So do you want to say I'm aligned with Intel or AMD or AWS? That's not kind of how you're choosing. What you really are looking at is what are the benefits that processor brings for your workload. And there are some workloads today that will only run on x86, and that's likely going to be true for all time. But when we looked at where the x86 processor is, you probably know a lot about Moore's law and kind of how that drove the processor industry. I always wonder whether the processor industry was actually chasing Moore's law, to give us that 2x improvement, or whether Moore's law was actually slowing us down, where they were saying, well, don't give too much because we still got to make sure the next processor can meet Moore's law. So it's a super interesting thing in how it sort of defined the industry. But in the early 2000s, Moore's law, everyone generally accepted that Moore's law wasn't going to continue at the pace that we had been seeing until then. And, it was put down to sort of physics and, the claim of sort of, have nuclear fission if you push this processor any harder inside the server. And so we better probably, we started to accept these 10 or 15% year-over-year or generation improvement, which was significantly less than we had seen. What was happening on the AWS side is, back in 2008, we started to realize that if we were going to make virtualization and the cloud performant, we wouldn't be able to do it all in software. And we started to look at hardware-based solutions that would give us the performance that we needed. Actually started with network offloading, which in the very early days of virtualization would see latencies as high as 300 milliseconds, not microseconds, milliseconds. And so it just would never have worked, again, for a lot of the workloads you wanted to bring. And so ultimately, we ended up buying Annapurna Labs, which is a chip manufacturing company or startup, and came and joined us. But it was really focused on how do we build hardware that allows us to give the performance that we need, and without impacting the actual central CPU in the box. And through the process, we ended up using ARM. and all of our Nitro cards, which is the system, what's the system called, the Nitro system, all of our Nitro cards are actually ARM. So my engineering teams got really good at building software for ARM. And we ended up spending a lot of time with the ARM team themselves to actually define what the chip looked like. And then in about 2015, we found ourselves in an interesting place. And again, if you think about what AWS wants to do, we want to innovate on behalf of our customers. We want to continue to find ways to give better performance at a lower price. And we looked at the x86, where x86 was, and we have fantastic partnerships with Intel and AMD and expect them to continue to grow on AWS, and there'll always be workloads for those. But we said, we could do something very interesting in the server chip space, given our experience with ARM. And so we started work on Graviton. And the real take on Graviton, the thing that we were going after, was can I improve performance and reduce price to a point where it became meaningful for customers. And so while the next generation of an x86 processor will give you about 15% performance improvement over the previous one, Graviton actually provided 40% price performance over the current x86 processor at the time when we launched. And so when customers look at Graviton, obviously they have to do work to move to ARM. For most languages like Java and some of the interpreted languages, it's easy. If it's C or something that's compiled, you've got to compile for ARM. So it's a bit of work to do. There's some libraries to find. It's not just to move your application. In some cases, you might be a challenge. But to do that work and then have a 40% price reduction on the other side of that, that's huge. And so that's what's really been enticing to customers, is the ability to do that and get that 40%. There's obviously other benefits, like Graviton just uses a lot less power. It actually uses about 60% less power to do the same workload that you do on an Intel processor. So in a world where power is scarce and we want to be more green as companies, that's a benefit for us. And then the other thing is, we continue in the pace of innovation. So we knew if we had a chip, we could continue to innovate on that chip. The other thing that's super interesting about us is we're not building a chip, a general purpose chip like you normally do, where you say anybody could take this and use it. So I'm going to right size that chip in kind of ways that I think would meet everybody's requirements. We're building a chip for a set of instance types. We know exactly what they're going to be, and so we can optimize that from the chip all the way through to all of the instances to really save costs, improve performance, and all that stuff. So Graviton 3, for example, actually provides an additional 25% of performance over Graviton 2, and came out about 18 months later. And so we're able to get that cadence because you're going from building chips and doing tape out and simulating in the cloud all the way through to working with all the teams that are actually going to build the servers and ultimately write the software on it. And so we have a very fast cycle in making sure that we can bring our Graviton to market. So those are the benefits that customers get. Obviously, we're always going to have customers that are going to be very happy on Intel and AMD and excited to see what they're doing. But for customers that really want that price performance and want to be have lower power consumption, Graviton's a really, really interesting option for them.
So you bring up a really good point. So a lot of customers are now sustainability, they have sustainability goals. Customers will put it into their RFPs. There are now sections for sustainability in their RFPs. So this becomes really important for them that are looking to fulfill these goals, to look at ways to do that. And this would potentially be one of the ways. So are there automated tools that could help a customer potentially assess their existing workloads on x86 and see if they're a good fit to move to a Graviton, or is this more of a professional services engagement?
No, I think lots of customers are doing it themselves, honestly. And the biggest hindrance to moving, and what I've seen, is actually more a customer assuming it's going to be hard. And so when I talk to them, they'll be like, oh, we got this library and we got this open source and I run on this operating system and what about, and so they've built this long list of things in their head that would have to change for them to be able to move. And my challenge to them is always, well, why don't you just give an engineer 2 weeks and see what they can do and really go and learn. And what we started to see is the customers would come back and say, actually, we moved the application and it's up and running. And they were able to get it done in 2 weeks. And what we found is the ecosystem has actually really ballooned for ARM. That's one of the reasons why we actually launched Graviton 1. Graviton 1 was actually the chip that we were using on our Nitro system at the time. It actually wasn't the full server processor. And the reason we put that out there in 2018 was to really sort of say to the ecosystem, server chips are on their way for ARM. So start porting applications, start porting operating systems, start getting those open source libraries and ISV applications ready for ARM. And so the ecosystem just took off. And by the time we brought Graviton out there, most of it was available. We do have a team in AWS as well, that if you have an operating system or a language or an open source app or a third-party application and that isn't ported, we do provide some assistance in going and getting that done. And so we've been able to unblock a lot of customers. But given where the ecosystem is today, for the vast majority of customer workloads, they can actually do that port relatively easily. We actually had one enterprise customer that did the port in 4 days and into production. And that's probably a little too fast, honestly. It's amazing that they did that. But it is a lot simpler than most people think.
So the new kid on the block is Trainium, right?
That's right. Yeah. So, we haven't just done custom silicon in the server processor space. Our first custom silicon was actually in the machine learning space. And, there was a chip called Inferentia, which is targeted at the inference side of machine learning. And then, as you say, Trainium is the new chip that we've recently released, which is targeted at the training side of machine learning. And it's the same concept there. We believe that there's something we could go and build from a custom silicon point of view that can significantly improve both the performance and the price that customers are having to pay. And when we launched Inferentia, the cost of machine learning really was on the inference side. It was sort of 90% of machine learning cost. If you look at an organization, we looked at Alexa, we looked at stuff we were doing internally. The cost was really that real-time analyzing incoming data and applying models and making decisions, and that's what inference is about. And so with Inferentia, we were able to significantly reduce that cost for customers, and that's been a great success. But what's happened is the models have gotten larger. In the last couple of years, these models are getting more complicated. They're getting much, much larger. They're taking a lot longer to train. They're being trained with more data. And so a lot of the cost of machine learning actually shifted over to the training side. And we have a lot of customers on AWS today training with GPUs to train these models and get them to a place that they can deploy them. And so that became a target for us to go and reduce the cost. And so Inferentia is going to offer about 40 or 50% price performance improvement over what you could do with the latest GPUs today. And again, just if you can lower the cost in what customers can do from a training point of view, they will train more. That's what happens. They want to, they've got a budget. They want to be able to train to that budget. And so we're allowing them to do more. The benefit of that is they become smarter. The application becomes better. There's better value for their end customer as well. And so that's really what we're trying to do with custom silicon in the machine learning space.
That's fascinating. I mean, I'll be honest with you. So with the advent of cloud and when cloud, and even virtualization to some extent, it felt like all of the innovation became more at the software layer, at that abstraction layer. And there wasn't enough happening at the hardware level. But everything that we've been talking about today, it feels like a lot of the innovation that you're focused on, I'm not going to say all of it, but a lot of it is focused on chip innovation, hardware innovation again. Would that be fair?
I think that's absolutely right. And I also think that it hasn't really changed in the lifetime of AWS, right? I think what you're seeing here is there's really no depth that AWS won't go to from an innovation point of view to continue to innovate on behalf of our customers, and going after that price performance equation of better performance at a lower price, at a lower cost, is kind of what we think our job is basically on behalf of our customer base. So if you go back to 2008, that's when we first started talking about hardware offload. And we realized actually that if we continue just relying on, as you say, software and a hypervisor that runs on the central CPU and stealing a few cores from the central CPU for our own software, we would never get to the performance that we need for customers. And that was absolutely true. And that set us on this journey, and I mean, today there are cloud providers that still do run software on that central CPU. And we can see that, by the way. If you take the same CPU, you run it on AWS, and you run it somewhere else, you can actually see the benefit of the hardware offloading because we don't have the steal time. We don't have the, even though I'm using 2 separate cores, it does affect the customer's applications to some extent. And so we've definitely seen the benefit of Nitro. We maybe haven't spoken enough about all of our hardware innovation, but if you look at an AWS server today, we're building everything from the motherboard to the CPU to we're doing SSDs now with the Nitro SSDs as well. And so it's just that sort of innovation story. Everything we have to go after, we'll absolutely go after it if we can bring price performance improvements to customers.
If you were to take a step back, and from Dave's perspective, and I'm not going to hold you to it as something that's official, but in a perfect world, where is all of this going? Where do you see what is the end goal?
Yeah, it's people always ask me, often ask me, are we nearly done with EC2? Like EC2 is one of the first services, and it really does feel like we're just getting going. And it's been an amazing journey. It's talking to customers and listening to customers, and getting feedback, and then building instance types, right? And developing new ways of improving performance, and finding ways of lowering costs, and finding ways of bringing new accelerators to the cloud. We just brought the Mac instance to the cloud. Like, if you asked me 5 years ago, would Apple Mac be running on AWS? I would have almost definitely said no. And we worked very successfully with Apple to bring, Macs to the cloud, and those have been incredibly successful. If you look at the last 15 years or so, one of the things that, two things have really changed, I think, the way that we exist. And one is the iPhone, the smartphone in our pocket, right? There's so much today we can consume from this device that we have with us at all times. But the other side of that has been access to cloud computing. And, I think so many startups today, which would just never have been able to be started in the last 15 years or be successful in the last 15 years, if they had the overhead of having to go think about building a data center or even just buying servers and putting in a colo, the cloud is just, and AWS has just allowed them to test those ideas. And if it doesn't work, well, they shut all the software down. And if they see explosive growth, well, it's there for them and they can take off. And so that's the way that the world has changed. I think going forward, in a couple of different dimensions. One, I think latency is going to become a lot more important.
I agree.
So what can we do as a cloud provider to make sure that our cloud offerings are just closer to users? And latency is super interesting because, 5G is part of that. And, our phones, many of them are going to 5G. And we haven't yet fully realized sort of 5G. It's more of a specification in many cases. We haven't yet actually deployed all the capabilities. But, latencies of less than 10 milliseconds and throughput in the, well over a gigabit of throughput, 2 gigabits of throughput really will change our devices, change cars, change, access to that communication. And I think in the next 5 to 10 years, you're going to see a lot of applications develop because of latency and ways that we wouldn't have previously imagined. And the other one's obviously just everything that's happening in the machine learning space. Just to see where the models are going and what these models are capable of. I think they are going to have a meaningful impact on our existence and lives, and finding ways to lower the price performance and also honestly lower the power consumption. It's a very, very, very power consuming workload today, and finding ways through our custom silicon to do that, I think is going to be critically important. And then the final one is just, what are we doing in the 3D space? We hear things like the Metaverse and
I'm coming to that.
And I struggle to get my head around the Metaverse a little bit, right? Like, what is it ultimately going to be?
We all are.
But I do think what's true is that our compute experience is going to become much more immersive. And we talk about the metaverse, but honestly, if you look at what's happening in some of the industrial applications of 3D computing, where people are doing things like digital twins, or they're doing things like being able to literally virtually be on an oil rig and actually, do assessments of that, or different ways of visualizing data, it starts to become much more real than, some sort of Second Life clone with better graphics, whatever it might be. And so I think that, and access to computing power with GPUs that can actually do that sort of 3D rendering in the cloud is something that, we have a lot of those workloads today, have a lot of big gaming customers running on us. We have a lot of game streaming, but the price performance of that has to come down as well for us to actually realize the reality, I think, of what the 3D immersive world is really going to be like for us.
I agree with everything you said 100%. And if I can put a little bit of a twist on it. So I feel like, when AWS started to announce outposts a couple of years ago, and even local zones, it felt like it was being done for a certain reason, get closer to certain workloads, especially rendering and other things. But I think as the edge is starting to mature, as we're starting to see a little more into the future of what can be, you mentioned the metaverse, there's, augmented reality and virtual reality. And when some of these consumer devices, like glasses or whatever, become a little more mainstream, then the latency is going to be super important. In these local zones and even outposts, the use cases for them is going to expand exponentially. A lot of times the criticism to AWS was that, hey, we feel like outposts or even local zones were a step to get folks into AWS. And I'll be honest, I was one of those analysts that believed, hey, we're going to give you AWS on premises, but that's a way to get you into AWS.
Yeah.
But as you start to look at some of these other use cases, I think the thinking has to evolve because now it has a lot more potential than what we previously thought it could do. Would you
Yeah.
agree?
Oh, absolutely correct. And for us on Outposts, we spent a lot of time looking. There were other solutions out there before Outposts, right? Which were the cloud in your data center, and they just never seemed compelling to us, right? It just never seemed. For us, cloud means that it has to be fully managed by the cloud provider. And it was really the coming together of Nitro with some of the latency use cases that ultimately had us say we could actually do Outposts. And this is how it would work. We're not worried about the security. We're not worried about API latencies. We could actually do that. And the realization that there are workloads out there that would never be able to run in a region. Unless we found some way to solve the speed of light problem, which we're probably working on somewhere in Amazon. But so the networking cable has to get shorter. That's the only way you can support those workloads. And we've had a number of customers use Outposts on workloads with latency is just something they would never have been able to move to a region to. And I think, as you say, with local zones being close to metros, less than 10 milliseconds of latency. Actually, in our Los Angeles local zone, we do a lot of media and entertainment workloads where they're filming footage on movies and TV shows, and they upload in it. And at night, you actually have people sitting with AWS machines and GPUs actually doing colorization and editing, and they see latencies as low as 1 and 2 milliseconds for that, which just changes the game in terms of how you access to the cloud. So there's absolutely workloads that will never, it's not a, hey, we'll put this here and hopefully your workload moves to the region. We're very serious about our edge strategy, and we just announced the availability of something like another 25 local zones over the next year and a bit across the world. And so bringing AWS compute closer to customers. And I also think, as you say, it's like such early days in terms of how latency is affecting application builds. And I think a lot of developers are starting to get their heads around that. And we're working with a lot of customers who are working on that as well. But it'll be unlocked at some point. And then, I really expect that edge to take off.
Yeah, and like you said, and I'm a believer. I mean, I'm a believer of this even before Outposts became a thing, that the only way that a private cloud or even a hybrid cloud would work is if we solve the management, the operations problem. Yeah. The whole problem with private cloud was always an operational challenge. It was never that technology wasn't there. But what do you say to customers that still want the ability to operate independently of AWS? Do you see a world where Outposts at some point can operate for extended periods of time?
Yeah,
disconnected.
Absolutely. I mean, one of the first customers that came to us when we shipped an Outpost was actually a cruise line. And they said, we love Outposts. We want to replace all of our servers on this cruise ship with Outposts. And they said, oh, but by the way, we go off to Alaska and somewhere up there, and there's no internet for like 2 weeks. And as you say, like Outposts needs to be connected. Like it brings a lot of value in being connected. But the way we look at that cruise line is we say, well, that's a use case that we should be able to support. And, I've had my teams working and they continue to work on saying, well, what are the things that means that Outpost needs to be connected? If Outpost is disconnected for an hour, what happens? And well, everything keeps running. Like there's not a problem, right? You just wouldn't be able to work new. But as you go like a day and then a month and 3 months, like what are the changes? And so that's absolutely stuff we're going after. And I think you will see Outposts, already you can disconnect an outpost for a lot longer than you could at launch. And over time, I think you'll see us, start to change the way that we think about that. And it's just finding, fully disconnected removes a lot of that cloud experience. If it's never connected, well, it's pretty much self-managed. And our Snowball devices actually do a really good job in that space, but it's a much smaller feature set. And then fully connected, you get that rich cloud experience. But there's a spectrum between the two. And I think you will absolutely see us starting to work within that spectrum on maybe I'll come back and connect once a month, or maybe I'll come back and connect once or twice a year, and then it can continue to kind of run independently between those times. So definitely something we're looking at and starting to understand what the customer use cases are.
I mean, I love the AWS culture because it's constantly adapting. So kudos to you. I mean, there are a few other areas that we're not going to talk about today that I would hope that would also adapt. But I love the message that, hey, we're hearing customers loud and clear. We are adapting. I love that the thinking is also evolving. You brought up some fantastic use case. I think the edge is the next frontier. And instead of thinking of how to bring everybody back into the cloud, you're trying to empower customers where they are at the edge. And I think that's going to be crucial, so that AWS isn't just cloud, but it's essentially everywhere. It's an ATM at every corner, essentially.
That's right. Yeah.
We are too close to reInvent for me not to ask you, and I know you're not going to answer, but I have to try.
Yeah.
What are we going to hear from an EC2 perspective at reInvent that you can share today The NDA stuff is the NDA stuff, but what can you share? What can people expect at reInvent?
Well, I think we're going to continue to push the envelope on innovation, and there's some very, very exciting things that we'll be announcing and talking about at reInvent, really across the space. And so if you think about price performance improvements, you just think about new technologies and that sort of innovation. That's what we do every single year at reInvent, and the teams are all working incredibly hard right now to make sure everything's ready to go. Everybody's working on their keynotes. I've had many meetings around what are we going to be talking about in our keynotes and positioning. And the same would be true on the networking side, right? The networking journey has been so interesting over the last 5 years or so, where we've gone from really being in cloud and then sort of thinking about how do we actually bring some of your on-prem locations there. And then last year we announced Cloud WAN. And so you can see it just sort of getting broader and broader and broader and helping customers ready to bring any part of the network. And I'd expect that journey to continue as well. So, really excited for reInvent. Unfortunately, I can't share any of the exact launches, but it's going to be a very, very, very strong year for us.
I would be remiss if I didn't ask this, and I know a lot of people would criticize me, but this is also one of the things that I struggled with when I was an analyst at Gartner.
Yeah.
reInvent was always one of those conferences that you can't miss it, but the problem was always the number of announcements, the number of new services, the newer names, the new branding. If there's one request that I can make towards the end of this podcast is we've got to find a way to combine, compartmentalize, maybe lead by industry. Hey, these are the services that as manufacturing you should care for, or as healthcare you should care for, because there was one year I think there was over 500 new services.
Yeah. And I imagine as an analyst,
incredibly difficult, right?
As an analyst, it's impossible to cover all of those.
Yeah,
it has been a problem. Like I remember with AWS, it was like 10 years ago, we joked because we used to, when we started off, we would say, only one launch per day, right? reInvent was a little different, but and now we need what we call the elastic calendar, right? There's just not enough space in the calendar because we're doing 3,000, 4,000 launches a year. And those are things that we actually, do what's news for, which are meaningful changes to services. There's obviously many tens of thousands of other changes we're making that we don't do what's new for. And then reInvent sort of is, sort of a list of ones that come at the end of the year. And we really do try and keep that for the larger features and the announcements. We actually even do things like Storage Day, and we've pulled some announcements early just to try and not have as many announcements as reInvent. But I think you have some good suggestions. There should be like a navigating and everything we launch type document that helps you by segment or area of the business to see what happened. It can be a little overwhelming and something we just got to keep working on. We don't want to slow down the innovation. We just got to make sure we can deliver it in such a way that customers don't feel overwhelmed.
I agree. So Dave, last question on this podcast. I heard that you are a collector of NFTs. You have Spider-Man first edition.
So that's clearly not true. I don't own a single NFT. I think the problem is I'm just too busy running EC2 to actually pay attention to what's happening in that space. So it's another area where I'm, intrigued, maybe similar to the Metaverse and see what happens. But I unfortunately don't own Spider-Man first edition. Maybe I wish I did.
Neither did I. Neither do I. But I want to thank you so much for coming on. This was fantastic. There was some amazing insights that you shared. Love to have you again. There was a lot of areas that there's just not enough time to cover, like networking and storage, that I'm sure we can do another episode on. So I'd love to invite you again, and maybe after reInvent to talk a little more about some of the announcements and some of the things that are coming out.
That sounds great. It's been great being here. I'd love to come again. Thank you very much.
Absolutely. Thank you so much for coming on, and we'll see you next time.